Hello, am I audible?
Yes, sir.
Great.
Yes,
Yes,
sir.
sir.
Okay, great. Let me pin my video. So I figured out how exactly this one is going to work because I mistakenly misplaced some wires. So that's why it is not getting it as I was in a bit dark. So these wires are very close to each other. And what I did is instead of 5 volt, I've connected VCC to VCC. So on our TTL converter, where it is, yes. So here on our TTL converter, there is a VCC pin, and that's supposed to go to 5 volt of the ESP CAM 32. So there is nothing wrong with my ESP CAM 32 board over here, and nothing wrong with the camera as well. So it is also functioning. It is also functioning. And the second mistake I did is that was that I need to select a particular chipset because here we are using AI thinker chipset, so that I need to comment off or comment out from the link. Let me show that thing. I'll just share my screen again. Okay, so here this is a camera web server code, and this one is the camera modules we can see. So ESP32 is a base board, or we can say it is a development board. So this development board can equip with various types of a chipset and various types of a camera. So here in our case, we are using AI Thinker camera module and camera chipset. Why? Because we wanted to take it ahead for any kind of a machine learning or security kind of application, and or we wanted to track persons, and we wanted to see that whether this profile is matching with our profile which is stored, and if that person is the same person, then allow some access. So kind of application if you wanted to develop, then will require facial recognition. So face recognition or facial recognition can be achieved in AI Thinker, because that is the name, artificial intelligence and Thinker module. So Thinker is a different module, and it is equipped with artificial intelligence. That's why it is AI Thinker. And the other, you can see this is a rover kit. So this rover kit, it means what? It is a similar kind of a development board, but only the slight changes. On that development board, we can get a LoRaWAN chipset. So through LoRaWAN chipset, we can transmit our video to on the cloud or any of the recipient where it is remotely activated. So on that remotely activated recipient, we can send that data. So that's why we can use, in that case, we can use a rover kit. So in that case, we need to uncomment this. Then there is another device or a development board called ESPI. Even if you can Google it, you can see differences in the development board as we can talk. Here it is ESPI. So ESPI looks like this one. So it is a slightly a bigger development board. So this one, this is a better one. So this is the ESPI. So depending upon our application, depending upon area of working, then depending upon the customization, like where we need to fit this development board, or do we required uh, functionalities like what ESPI is providing, because ESPI is having a very good camera on it, which can sense up to 5 MP of a resolution. So it is possible that we can get 1080 resolutions of HD pictures. Though AI Thinker is also doing the same, but only the difference is we are getting a low resolution camera, so we can achieve 720 pixels per ratio for our live stream or our live footage or camera, what we are focusing on. So accordingly, there is a M5 stack. So M5 stack is another development board like Node MCU. On that, it is going to mount. Rover, ESP, and AI Thinker TTGO. So these are similar to Node MCU, but M5 stack is totally different. Their schematic is different. Their microcontroller is different. Some ICs and chips are same as it is used in Node MCU, but it is totally different than the each other. The working style is different. But still, camera module or camera functionality is the same. So this ESP32 camera shield is going to work, and this code is going to work in all the models. So currently we are having AI Thinker module. So we'll go with the AI Thinker. I have uncommented this. Defaultly it is uncommented on Rover Kit. So that's why the error camera detected fail or camera did not respond. These kind of errors coming on our serial monitor. Now I think it is not, it's supposed to not come, because I have already rewired all, and now it is taking a continuous and still picture. Even it is going to connect on our uh, RX100 access point. So what I'll do is I'll just plug in this. I will stop my presentation and I'll ping my video so we can all see it properly. Okay, so these are the connections. Sorry, these are the connections what I have made. So previously this 5 volt, the blue cable 5 volt was connected to VCC. So now I have rectified it to a 5 volt, and now that jumper what we created, the loop what we created, that is only required at the time of burning the software or burning your code into Node MCU. Otherwise, it will not required, because Node MCU is not having any auto bootloader functionality. So once we are keeping it into a loop, it is automatically putting it, or we can say manually. It is not automatic, so it is manually putting this into a booting mode. So right now we don't require any booting mode, so we'll just directly connect it with our power supply. So in this case, we are using only USB power supply, which is sufficient enough. Now I have already powered it properly, and now I'll share my screen, because all other things we need browsers to operate. Okay. Now I have already uploaded the same code. Now what we'll do is we'll just open up our serial monitor. So we have opened it on COM10 115200 baud rate, and now here I'll just restart the module. Now you can see over here it is trying to connect. Now it is showing Wi-Fi connected. Web server is on port number 80 and streaming server is port number 81 is connected. And this is the IP address what I have gain on my ESP32. So I need to browse this IP address in order to see the live footage. Now we are viewing on port number 80, and that is the default HTTP port. So these are the different options what we can get with this module, and the camera what we are seeing, it is a OV2640, sorry, OV2640 camera. And we can adjust a lot of settings, like we can have a quality. So this quality is set it to a minimum, that is a 10 pixel, maximum it is 63 pixels, so 630 pixels it is. So this is a 100 pixels and this is 630 pixels. Brightness we can have, contrast of resolution, and the most important part is over here, this is the face detection and face recognition. So now I'm not having my SD card inserted, as unfortunately I'm short with the SD card. No, I'm having a SD card, but I'm not having a SD card holder. So that holder needs to be inserted here, for the lock. So I'm not handy with that. So that's why I'm not able to save anything. But I'll explore this functionality for you. Before doing that, let's see what kind of a picture it is taking. So resolution is set to 400 by 296 pixels, and you can go high as a can 1600 by 1200 pixels you can go. So this is the maximum capacity of this OV2640 camera lens to capture and give a what we can say, quality. So once we selected this, I'll go with the basic one first, and then we'll change the quality so we can notice the difference. Now here we'll have two option. Like first option is get a still. It means what? It will just capture a photo. So right now I'm facing it to my laptop, or what I'll do is I'll just face it to our photo here, and I'll take a still. So once I click on a still, it is a bit, it is good now. Let's take a still again, or rather what I'll do is I'll check him out from the dark, and I'll try to snip. Now you can see this is the actual snip. Again I'll take the still. Now this is okay. It is sometimes very tricky to hold our camera still. Okay, now it's supposed to take a good angle. Okay, I lost. I'm not able to make it still. Maybe last try. Yes. Okay, fine. So here it is. We'll just take it another one. So here is our. But if you can notice the quality, what type of a quality it has captured. So we can increase the quality now, and I will try to capture a snake. So as my hand is shaking a bit, that's why I'm not able to hold it still. And the camera here, if you can see, it is also shaken up because it is not having any kind of a support behind. That's why if you notice here, it is when it is just have a slight jerk, though it is moving. So it is very difficult. I'll just try with hand. Yeah, it is a better picture now. Now these are the pictures only that where we can capture. We can have streaming. So this is a live stream what I'm having. If I can move around, we can see our screen and screen and screen. I'll move around to it. We can see our drones. Don't see other stuffs because it is a messy table. So here it is. It is giving us a very good picture. So we can implement some other applications, like here it is a face detection or face recognition. So let's try this. um, Opening up with the face detection, it is saying that please select CIF or a lower resolution in this. So it asks us to take the lower resolution so it can save our uh, space, the image space. Now here our face detection is enabled now, and here is face recognition. Both I have, even if I just enable a face detection, then what will happen is I'll just open up a live stream. This is a live stream now, supposed to capture me. Yeah, so it is capturing me now. But if you notice that it have created an outline over here. Now even I can enable face detection and face recognition. Now here what I'll do is I'll stop stream. I'll click on enroll face, and I think it have enrolled the face. Look at, yeah, click on enroll face, but it will not going to work. It's supposed to give a pop-up saying where to save the file. as we don't have SD card in slot. It is not going to enroll the face. So basically what enroll face will do, enroll face will capture a good image, and then it will be stored. And when next time if you wanted to use a camera for unlocking something, or just have attendance, or just have instead of thumb you can have facial attendance, so in that case we can use this camera. And it is a pretty good camera, and for 700 rupees it is a very good resolution what it is giving. And we can create a good product, or we can create some projects out of it. So I'll click on stop enrolling. Okay, so we can extend our switch, or our relay project. Instead of taking a PRI, we can have ESP Cam 32, and we can have a profiling done, and we can allow those only users who are or what we can say whose profile is already in our module. So that way we can have a better control over the persons, or the if you wanted to have authorization over the entries from this kind of a project, we can have it. Now the another interesting project what we can do is, along with this which I wanted to show you, that with the PIR only, not with the PIR actually. It is a IR, not the PIR. It is just a infrared receiver. So through IR, we can count our entries. So how many entries have passed through the gate, and how many are out from the gate. So that kind of entries we can capture. Even if we are modifying our relay program only, so we can have like once someone enters, automatically it triggers the counter, it counts the person, and then it automatically switches on the light, or switch on the relay, and associated appliance will take on. Once the person is getting out from that room, it will again check for the counter. So I have modified our light application only. So what I have did the modification, instead of PIR I'm using IR. Then instead of just checking the motion, I am counting the motion. So how many persons have entered, and then it will eventually capture the count. Once that count is reaches, so once we stop entering from the door, then it will log it, maybe 4, 5, 10, 13, or we can implement like in our one batch there is 30 students are there. So 31 persons are entered, 30 students and one professor. So 31 persons are there in the room. And once everyone is getting out, it will again start decreasing the count until it reaches to zero. Till that time, that light will turned on. In our previous PIR, what will happening is PIR is having a timer. Once that maximum timer is reached, automatically it turns off the light. And then again, when a motion is detected, then it is turning on it. So it is having some kind of a delay. But in this case, we are not experiencing any kind of a delay. When the counter sets to zero, automatically lights turned off. So what will be the system requirement for this? We'll be requiring two IR sensors. So here is a IR sensor. So we'll require two IR sensors. Even a one IR sensor can work, but it is not that feasible, because that is the only sensor which is taking a track of entries, and that is the only sensor which is a track of entries which are getting out. So these sensors are passive sensors, so these are not that intelligent sensors. So maybe because of the lack of intensity, it will not hold the values. So it is better that we can utilize two IR sensors. So one we can place outdoor and one we can place indoor. So once a person is entering into the room, then the indoor sensor will sense it and then increases the counter, and or the outdoor will be capturing it, and once the person is getting out, then indoor is capturing it and decreasing the count, and accordingly light is turning on or off. Or even you can trigger some other things as well. So if you are thinking about creating a smart sanitizer tunnel, then there also you can use the same principle where or the same idea we can see. Not the principle, actually the principle is pretty straight. It is just taking up the obstacle, and once the obstacle is detecting, it is turning on or off depending upon what it is coded. So if you are creating a sanitizer tunnel, automatic sanitizer tunnel, once someone is entering into that tunnel, automatically first IR will detect the motion or detect the count. Once the count is reaches, once you reaches to the tunnel, automatically sanitizer will get sprayed. And once you pass that tunnel, automatically the second IR will decrease the count, sending a off signal to that spraying system to stop. So that kind of application you can again build. And even I'm sure that maybe you have already created some similar kind of application before, because there was actually a flood of different applications to avoid COVID and the cases of the COVID, detect the COVID ratios. Even there are some applications. Even I was mentor for one PhD project where those PhD scholars was supposed to develop one application which is monitoring a system, monitoring a person's health, and depending upon what kind of a diseases that person is having, and depending upon the respiratory diseases that person was having, it is calculating using a ML. It is calculating that whether that person will have a chance to be infected with the corona or not, and if that person gets the corona, then what will be the chances of severity or critical health in that case. So that kind of application, I think so they have already made it. Okay, so here is a system diagram of the IR tunnel. Let me pull up it. Let me just share my screen. Okay, I think it is already shared. So this is the diagram. So here I have used Nano, Arduino Nano, but you can use any Arduino board. So right now it is Uno is handy with me, so I'll be not taking Nano, but you can do it with the Nano. Then we are having two IR sensors which are interfaced to the 5 volt of the Nano. Now, if you can see, we are having one, two, three, and four different sensors. This is the analog display what we are having, which will display a counter. So here it is a small display, but instead of this, you can have a big LED or a LCD kind of a display, and you can interface it with Arduino, and you can display the count. So it is like you're going to a bank, and there is a counter system or token system, and the token is getting displayed over a LCD screen. So it is similar to that. So you can always have that. And then we are having a single relay, or we are having a relay. Once it is detected it is detected a count, then automatically it turns on the light, and it counts reaches to the zero. Like this one is detecting a count who is going out from the room. Once the count is reaches to a zero, automatically relay will shut off the light. So here we have two interfaces. One is a out, which is a signal pin. The first IR signal pin will go to a digital 3, because these two are the digital sensors. It will capture and emits the digital signals. So the D3 is connected to the first, and D2 is connected to a second IR sensor. Then ground will go to a ground. So I shorted ground to a single ground. So even I can use other grounds here, but it is okay. That ground is a ground. Then we are having a VCC. So here VCC will required by both the IR, and both the IR is requiring 5 volt VCC. because these are the digital one, and it is having some other functionality, like they are having some diodes, potentiometer to adjust its intensity. So for operating on those conditions, it is requiring high voltage. So the 5 voltage, which is a maximum one, so it is working on the 5 voltage only. So that's why 5 volt is given to both the IR receivers and sensors, and the 5 volt is required to our relay as well. So I have shorted it to the 5 volt of nano. In other hand, for a display, these are the I2c displays. These are not SPI displays. So what is the I2c and SPI is? These are the display type and the chip type. Depending upon that, the pinouts are designed. So these are the 4 pins. So whenever you see any display which are having 4 pins, especially one is a ground and one is a voltage, instead of that, only two communication pins, one means SCK or SCL and SDA. So that is for reading and writing the data. So write and read streams plus two your connection pins. So when you are having 4 pins, that means it is I2C ports. And when you are having 5 or 6 pins a connector on the any display, then it is a SPI display. So we'll take SPI and I2C in our protocol session. So there I'll be explaining you why there is a difference in that. Though the pretty straightforward difference is the chipset what these devices are using. So here I'm having I2C. Now depending upon the size of your display. Now it may look bigger here, but it is actually a smaller than what it looks. So I'm using a 0.96 inches display. I'm having two displays. One is a 1.3 inch and another is a 0.96 inch. So I'm using a 0.96 inch display to display this. So this is a simple diagram what we are having. And this is a simple code where I have included Adafruit GIF, GFX and SSD1306 library. Now, what these libraries are? These libraries are required by your display to output the signals, because this display is an analog display, so it will not understand any digital in or digital out as compared to the signal what is coming in. So that needs to be converted and it needs to be graphically present. So GFX, this is the header file for graphical representation. Now the display what I'm using, it is a analog single color display and having a blue color in it. So it will have a blue screen. We can have a multicolor display, that is a color display. We can have the RBG color display, which is having multicolors. Even we can have a black and white display, we can have pink, we can have green. So these are the different types of displays what we can have, but widely used is a blue and color displays. Then the SSD 1306 library is used to have a input, which is again what will be the appropriate word for it? Yeah, so the input can be read and can be output, can be created output in the sense that that display can able to display it. So basically, these two libraries are for the display and to display it properly. So after that, I have defined screen width and screen height. So according to the display, we need to set this. So I'm having a 0.96 inches of a display, which is having a 128 pixels a width and 64 pixels a height. So it is not inches, it is a pixels. So I'm having, again I'm repeating, I'm having 0.96 inches a screen, on that 128 by 64. So it is like that. So 128 pixel by 64 pixel is a screen resolution, so width and height. And then it needs to have a LED reset pin to ground the signal. And then the Adafruit SSD library is taking care of the wiring and display purpose. Then I've defined in sensor and out sensor. Means what? The in in IR and outward IR. So that's why in sensor and out sensor accordingly 2 and 3. So in sensor is on digital 2 and out sensor is on digital 3. Then I have given the status. So in status is defined in a data set of integers. So the data type for this variable is integer, so it will hold a number. So in status and out status. Similarly, count in and count out. So this will display on our display. So whether the count in, how many number, how many persons are in now, so that is the number, and out for that number. After that, in and out is again displayed over it. Now finally I've defined relay pin on the 5. You can display relay pin in any available port, but it needs to be a digital port. And then the rest of the thing is displaying one. So pin mode is when the in sensor is input, means when in sensor is getting a signal or out sensor is getting a signal. What you need to do is you need to do a relay output. And once the relay is out, then what kind of a message you need to write? So on a digital, write relay high, means relay needs to be on. So it is commonly on or normally on connection. And similarly we need to display it. So we can clear a display, we can set a text size, we can have a text color which is a white in this case, or I can display blue. But I'll be not displaying in a blue color because the screen is of a blue color. So on the blue is not going to visible. So then the set cursor to 2020, it is a pixel. And then on the first time when it is booted up, it will show visitor counter. So this is the print statement what I have made. So this is the space, the pixel space where the first line, that is a visitor, will be printed, and this is the second line where the counter will be printed. Then it will have a delay of 3 seconds, and after that the loop is going to start. So if the first sensor receives the signal, turned on the relay, as well as make the in display as a counter 1. Then once the output display output IR is captured the signal, then again do the reverse of it. So this is the program for this. So I have already burned it in our Uno. So what I've did is I'll just open up my camera. I'll just stop presenting. Okay. So what I've did is, so here is our Uno which is sandwiched with the sensor board. On the sensor board we have 4 sensors, 2 IR, 1 OLED display which is a 96 inches, and 1 relay. So this is the connection what we have. So now I'll just place it properly, and then I'll move camera so we can see it properly. Just give me a minute so I can place it in a proper way. Okay. Okay, so here are 2 IRs. So if you can see over here, the first IR here, it is not displaying any movement as the only one light is on, as the one LED is on. And if you can see the counter which is moving, as the this IR was receiving a signal. These are very sensitive, as I have made the sensitivity high. And here is our uh, relay which is turned on. If you can see over here, the LED is turned on. So here is the relay which is turned on. Why? Because of the activity. So here it is activated, here again it is activated. So what I'll do is I'll just keep this aside. Here this one is also, and on the screen if you can see, there is a counter which is running on, and it is still climbing because it is sensing my movement. Okay, now it is stopped. At now you can see on the display it is showing current visitor 75 visitors are there. Now why this counter is counting, because this is a simple IR. So once the signal is interfere, then it is taking the counter up. So counter is increasing. So if you can see, total number of ins are 147 and total number out are 72. So 75 visitors are still there inside the room. So what I'll do is now, I will place it here. Now I'll start moving here. So now if you can see, counter is start decreasing. Now it is detecting that these many persons are getting out. So it is not possible that each second person can just walk through from this room. But again, this is the illustration one, and you can set the delays accordingly. But this is the real time one, so I'm just making it go back to 0. And if you can see, eventually it is showing that output is 1112, and these are the out visitors. So these many visitors are out, and in ratio is still there. Now till the time, if you can observe here, this sensor which is responsible for taking the counter for in, now our relay is off. Why? Because the visitors are now left the room. So here it is showing no visitor, light off. So the status is light off. So once I move my hand here, it will detect a motion. Now it have detected a motion. It's supposed to turn on the relay. It will wait for 3000 seconds, and then it will reset. Maybe I'll just repower it. Because today only I have made this connection, so I need to check for the possible bugs in it. Just for our demonstration, I have made it. So you can see no visitor, light off. Now if you can see, there is a visitor because I've touched it, and there is a light. And again, now I've touched to the second sensor. Now I'm making this way you can see properly. I'm making, because the sensitivity what I have set it is very low. So I need to place my finger very near to the sensor. But if I set it the sensitivity to a very high, it can sense up to 5 to 10 meters. Now it is showing 3 as the counter. Now it will go off. Now it is turned off. Again I'm doing the same, turning on. Now turn, it is turning off. So by this also we can have our relay which can be turned on and turned off. So the automation can be achieved from this as well. Just we need to see the sensitivity. We need to trigger the sensitivity properly. We need to set the sensitivity properly. Like here also, I'm setting the sensitivity to very low. That's why I need to place my finger very near to the sensor. So once I turned it clockwise, it is turning the sensitivity on, and highest is up to 6 meters, 6 to 7 meters. But if we are taking a good sensor and placing it into a good environment, dust free environment, then it can sense up to 10 meters. That what the experience I was having. So 10 meters, up to 10 meters, it is properly sensing. Yeah, so are we clear till this point? Any question, any doubt? Okay, so I think there is no question or any doubt. We good till so far. So what we will do is now taking this automation only ahead. Now we are doing it everything manually. So if you wanted to control the entire automation remotely or through mobile phone, how we can do it? So for that, Node MCU will come for our rescue. So here, let me take the Node MCU out. So the Node MCU will come for our rescue. So what we can do is we can create a portal where we can display some buttons, and through that we can control our relay. So it is like that. I'm having an application like there are different applications. Blink is there, or there is ThinkSpeak, or there are various applications we can create. Even the Android application we can create, and we can integrate that Android application through Node MCU. But that only the thing is Node MCU need to be connected to internet, and that Android application needs to connect with any of the cloud services. So maybe it is a ThinkSpace, maybe it is Cygen, or the IoT. What was that? MIT IoT, or we can have Azure, or Amazon. So any of the mediators or the middlewares where we are connecting through REST APIs or APIs for that. So once we are connecting to it, we can definitely control our devices. So we're not going to connect it today, as we are having a special session for it. So how we can write REST APIs using MQTT portals, having APIs using, or the secured APIs even CoPAs. So for that we are having a special session where I'll be showing you how to write them from scratch, and then we can control the device. So in this session, what we'll do is we'll program this tiny friend to operate in such a condition that it can emit the access point. So this needs to be into access point mode. The normal mode will not function over here, or the station mode will not function. Even the station mode will function, but we need to be in that range, or that network's range, to connect with it. So instead of that, we can have Node MCU with us, then it needs to be into access point mode. Once it is into access point mode, up to 5 devices can get connected to this, and we can control our switches or any of the elements what we have connected on this by remotely, or by just having a mobile phone. So that way we can do. So for this, what we will be requiring, we'll be requiring Node MCU, of course. After that, a relay will require, and a small program. So here I'll be borrowing our relay from our previous application. So here is our 4 relay. Then we'll require some jumper wires. So we have jumper wire over here. So what we will be doing is we'll require jumper wire, like we can control our relay in the bit. So we'll control 2 buttons and 2 relays over here. So I'll be requiring 4 jumper wires. One is to give power to relay, and other one is ground, and two for, or one, two, three. I'm having 5 jumper wires with me. So let's control 3 relay switches. So I'll just make the connection. Now, making a connection, you're already familiar with this. I'm not repeating it again. Okay, so the connection is done. Now here we need to follow one diagram. So just I'll just open up that program so we can see it. Where it is, where it is. Okay. So here is a system diagram. So this we need to connect. Just unpin it. Okay, so here is the diagram. So what we are having in the node MCO, we are having GPIO or GPIO pin. So what we need to do is one is need to be going to a win of a VCC, because the 5 volt needs to be supplied to our uh, relay, as this is a 5 volt relay. But on a node MCU, we can see only 3.3 volt, right? So 3.3 is not enough for relay to trigger, so that's why there is a extra port for external power supply, so that is a win port. So from win we are giving a power to VCC, that is a 5 volt to the VCC, and then ground to the ground. Then we are having these GPIO pins. So these are the GPIO 5, 4, 14, 12, 13. So what I'll do is I'll give this diagram to everyone on the group, so we can see it properly with the codes, of course. So I'll be uploading it on G Drive, and that link I'll be sharing. So according to this, we need to wire our relay, and then we can control our relay. So the first one is a GPIO 5, that is a D1. So D1 will get connect to the first relay. So first of all, we'll connect with the ground, and then we'll give a power. This is the power one. Okay, so now this is the first. First, we'll go to D1. So D1 is here only. Yes, so the D1. According to the second will go to D2. Then D5 is going to connect on D4, and then we are having D5. Okay, so we done with the connection. Okay, so let's burn this connection in node MCU. So this is the program for this. This is the program. Now if you can see, I have already written this program, and I have created this node server or the node MCU into access point mode. Now this access point mode will be creating a SSID called softtech, and the password which is test underscore test node. So a client needs to connect with this node MCU using these credentials. And then the control panel, what we have created, that control panel is going to be displayed on IP address 4.1. Now this IP address is going to be given by node MCU only, because this node MCU is now in a access point mode. So let's burn this. So before that, I'll just take the appropriate board. Once we done with the program and demonstration, then I'll explain the code, which is a very simple code. Then I need to select the port is already selected, and I need to upload it. It is compiling it. It will take a bit. From 14 this field. Why? It is. Let's try it once again. Sometimes these software ports are not getting recognized, and maybe the reason is my serial monitor is somewhere on, but it is not on here. Maybe it is on here. No, it is also not here. Okay, or I'll check with the another node. Okay, maybe the com issue. So I'll just change my port. This is supposed to turn on. Maybe this is the issue with my machine. I need to restart my machine. Then only it is going to upload it, as it is not recognizing the port. Yeah, now it is COM4. Okay, now it will do. Now it is connecting and it just start burning. Ah, my bad. Okay, now as this is already created, I will just press the reset tab once, and now here we can see one more. Is my audio video coming? Yes, I think we are connected.
Yes, sir.
What I will do is I'll just take another USB Wi-Fi so we can connect with it. So as you can see over here, it is already having a soft tech as one access point ready. So we need to connect with this in order to operate. I'll just Now the Wi-Fi 2 is on. Now Softic is connected to it. Let's browse on 192.168.4.1. Now this is the light smart light web control which looks like which is in the node MCU. Now here are the GPIO pins. So the same GPIO pin what we have connected. So light one is on GPIO 5. So if I turned on it, automatically it turns on the light. If I turned off it, simple one. Now here is a second, here is a third, here is a fourth. Fourth will not work because fourth is not connected. Fifth is not connected. Okay, so we are having three: first, second, third. These are properly connecting as we are having only three ports which are connected. So by this you can control any appliance by just onto node MCU, and we can connect with the node MCU, and we can always what we can say, control our devices through our any device. So moving on to the code of this, I've just turned off all the lights. So what we are having here, we included ESP8266 Wi-Fi libraries, web server library, and Wi-Fi header file. So this header file is responsible to take your node MCU into access point mode or on a station mode. Access point mode means what? It will work as a router where you can connect with it. Station mode means what? It will work as a client where node MCU will going to connect with any router. There I have defined relay pin number to true. Now why relay pin number to true? Because there will be a multiple relays which are going out, and number of relays are 5. So the 5 number of relays I have defined. So here I'm having a 4 ports of a relay board, though it will work in that way. So the GPIO pins is 5, 4, 14, 12 and 13 which we connected as we can see in this diagram. So this is GPIO 5, GPIO 4, GPIO 14, GPIO 12 and GPIO 13. So similarly we have connected like that. Then we given SSID and password to our access point. Then parameter input 1 and 2 is relay and state. Now what is a relay and what is a state? So now once we are on the relay over here, if I move again, I have already connected to it. So you can see over here the light 1 GPIO 1, and it is not turning green. So this is the status what we can get. And similarly, if we have a bird rate over here, I need to select another com. I need to restart my machine so it will recognize the com. But still, on the serial monitor, once we are clicking on a one button, automatically that status is coming on onto our serial monitor. That state is changed, like it will show like on number one, on number two, off on number one, off on number two kind of a state. So that's why it is an input state. Now currently input state is 0 because everything is turned off. After that we have synchronized web server port number 80, and this is the HTML script what we have already coded for taking this user interface. So for this user interface, this is the code which is responsible. This is a simple HTML code. So there is another feature of this IDE, that this IDE can let programmer to integrate different program written in a different language and can be associated with the node MCU or any of the development board. So the node MCU is very versed connected to a properly connected to a HTML type of programming. So here is the HTML code for this. Even I can change something and I can upload it. Like here, I'm writing a smart light web control panel, so this is into a header 2. If we all know a basic HTML, then also we can create this. So here is a style tag where we are defining a style which we need to have for the font needs to be a bolder, it needs to have this font size, or this needs to be what type of style we want, or the font we want, so that we can define here. At the body, what type of the action we want. And then we are having processors, and then we are having GPIO pins, so that button code is here. And then finally we are writing out the relay switch on switch off buttons, that once the relay is no, that means normally open, then what needs to be written. And once it is not, means it is normally closed, then written checked. It means what? It is already passed, so it is already opened. Light is on or light is off, so that we can define over here. Yes, so this way we can extend our project. So the IoT is not only about just interacting with the sensors, or just taking a two or three sensors and putting it together on a development board and we done, but we can extend the project like this. And if we are having a one single idea, we can create other sub ideas out of it, or we can fit it into a different dimensions to create a different quality kind of a project. So these kind of applications which are generally working, and these are the prototypes what I have shown you. These are the prototypes of the actual implemented ideas, like the PIR sensor that is already implemented. But we don't know, sometimes we don't know how the this PI, even we don't know which sensor it is. Now we are just able to understand that is the PIR sensor, which is detecting a human body signature or the body temperature and turning on the light. Now there is a IR sensor on the various instruments, like when you are getting into a any room, or take example like when you are visiting to a shopping mall, that sliding doors are automatically opening and those are automatically closing up once there is no one. So that time there is a IR sensor which is responsible for that kind of action. After that we can have a metal detector. So there are different kinds of sensors which are tuned to detect various metals. So there are metal what not the metal detector, of course those are the sensors which are metal detector, but those are the light sensors which are reacting on the certain pattern when a particular metal is what we can say interfaced. So if there is a metal which is used in guns, so maybe that is modified iron. So that modified iron is passing particular infrared or light in a specific pattern. So if that pattern is matched, that means that that person is having the metal which is used in gun. Or sometime it happens like if that metal detector is so sensitive, if you are having your car key or home keys with you, then only it is detecting something is in your pocket. And once you take it off, then you'll pass it very safely. So that kind of a thing. So those are the light emitters, or some are ultraviolet light, some are infrared, some are general light, some are beams light, some are lasers. So there are different types of the lights which are reacting on the different types of metal in a very specific pattern. So that pattern is matched and that pattern can be coded. So the similar thing, it can be a base idea for you. So if you wanted to try, then you can try to create a metal detector by getting the light emitters. So what I'll be doing is I'll be sharing some information on this on the group once we done with the FDP. So if anyone is interested, they can take up it as just a hobbyist project, and we can create or we can simulate metal detector at our home or at our workplace. So yes, so this is for the second session. So we are open for the question answer for second session. If you are having any, we can open for that. So please ask your questions. Is there any questions?
No, sir.
Okay, okay, great. So we'll take a small tea break, and after that we'll resume.